Hello. Oh, it's quite loud. I'm here to talk to you today about container security. To give this talk a kind of catchy title, I said it was 10 tricks. There aren't exactly 10, and I'm not going to make lists because security is not really about lists at all. So there might be slightly more than 10, but we'll come to that in a minute. I work at Docker in Cambridge, UK. It's nice to be visiting Italy. It's not too far away. I have both a dev and an ops background. I started off doing operations and started doing dev later on. I work on a load of different projects at Docker, mainly on open source. I work on Docker Engine itself and our Kubernetes work we're doing now. I've worked on lots of the different security pieces inside Docker Engine, like the seccomp policies and the kind of complicated bits. I also worked on Docker for Mac, desktop stuff, so quite a varied bunch of stuff. Cambridge is in case you don't know it, it's a kind of tech village, I like to think of it. It's this is a bunch of telescopes in the countryside because we keep our countryside's full of science rather than agriculture. It's a bit of a weird place, but it's good fun. And security is about sleeping soundly and not really panicking, thinking about all the things that could go wrong. And that's the aim of this. Here's a picture of what sleeping soundly looks like. But being in security, it's slightly deceptive because it's not actually a real hippo. So maybe you won't sleep that soundly because it's actually made of mud. As I said, they're not going to be exactly 10 things, and this is not going to be about lists. It's going to be about thinking about what security is about, how you can make it better. So don't try and write down a list of 10 things and tick them off when you've done them, but try and remember one or two of the things that I mentioned, or even 10 of them, or all of them, but just try and improve the way you're doing things. Just think about security a bit more while you're working, and things will get better and you'll panic less. Why containers? Containers are good for security in many ways. One of the things about containers is you know exactly what you're shipping, and that's really helpful because when there's a problem, you say, I know exactly what we had in production on the day that our server was hacked. You can look at it and say, look, this seems to be the problem. And then you can ship a new version, and each time you ship it, you know you're shipping the same thing that's got the fixes in. And you can do this quickly because containers help you do things faster. And it's usable, and usability is really important for security because difficult things are not things that people actually end up doing in production. So one of the kind of policies we've had at Docker is always to make sure that the defaults are sensible with containers. We fix the basic lot of things that work for most people. And so you don't have to that the usability is there, and it's really important for us. And if things don't work for you by default, then please complain, and we'll try and make things work for you as well. So I think definitely using containers does help security, and for these reasons. But the thing that helps security most is working together as a team. Security is not something you should be thinking about on your own. It's something you should work with your whole team. Don't say, security is just the ops people's problem in deployment, or security is just developers' problem. The ops people just ship whatever they say. Work together to deliver quality software with everyone in your team. And remember that security is, as I said, it's not a list of 10 things that you have to do, and after that it's done. It's a process that you need to think about all the time, and you want to get better at it over time. something might happen. There are big company hacks that you read about, like Equifax, and where things go terribly wrong. Most of the time, there are ongoing things, but you need to learn from them and not just blame someone. Oh, it was John's fault at Equifax. Fire him and and apologize. It's not going to help. You really need to learn how to do things and share your learnings with other people. And one of the things that we do at Docker, which I think has been really helpful for improving security, is embed a security person in your team. So every new project has a security person assigned to work with the rest of the team and ask the difficult questions about security and think about it. You have to explain to them what you're trying to do, what you're trying to ship, how it's going to work, and they'll sit there and think about the problems and make sure you think about the problems too, and review the bits of code that are security critical. Not every company has the luxury of doing this. It does require you to have lots of security people or some security people. But if you don't have that kind of team because you're a small startup or a small company, or you don't have that kind of culture, assign someone to do that instead. Make sure that someone's responsible for security and plays that role and asks the questions and says, what are the risks with this? What's the worst thing that could happen? What kind of things might happen? What kind of things haven't we thought about? What kind of authentication do we need? Who's supposed to be able to access this? All those kinds of questions. They vary a lot depending on the project, and each project has different requirements, but someone needs to sit down and work out what could go wrong, and if something does go wrong, why did it go wrong? How can we make it better in future? And so this is kind of, this working together as a team thing. If you ignore the rest of the presentation, just think about these things are the important things, really. And obviously they apply regardless of whether you're using containers or anything. If you don't ask the question, what could go wrong, then you'll be surprised when something goes wrong. Counting of things again. 4 things you can do if you're a developer, which these are things that you should be able to apply kind of quite easily. Docker has, and Kubernetes as well, have loads and loads of options, and one of them is privileged. And privileged has a few use cases, but you should not be using it in production at all. Basically, the idea of containers is to contain things, and if you run with privilege, you're no longer containing anything, so you're not really using containers anymore. And it's useful for debugging, it's useful for weird system things, but it's not something you should be using in production. And a lot of the other security options that you can grant are actually pretty much the same. They remove the isolation that containers give you. And so don't use them in production. Don't use things like sudo. Basically make your containers as simple and straightforward as possible and not require any kind of privileges at all. The security op, no new privileges. There's a Kubernetes version of that as well now, since 1.8. It's a kind of weird and obscure option, but it makes sure that you can't use sudo. Again, that's a tool which is great for development, but you shouldn't be using that in production. Don't run stuff as root if you can possibly avoid it, or use user namespaces, which do the same thing. There are a few issues, I say if possible, because there are a few issues with things like volume ownership, which sometimes make this difficult. We are working on trying to fix those and make that easier, and there's ongoing work, and one day we'll be able to remove the if possible bit, but give it a go and try. Lots of things don't have to run as root. Debugging and things like that, they're fine. And if you're playing around, learning about containers, all these things are really great, but they're not designed for production, and try and avoid that. wherever possible. You use read-only images. It doesn't give you huge security advantages, but it means that none of the files in your container can change, which is great because it means you know that you know exactly what state your container's in. You know that nothing's modified it. If you have a problem, everything's exactly how it was when you started your container running, and there isn't some sort of weird, hard-to-debug thing. Some images don't work with read-only, which is kind of annoying and file a bug, especially on the official images, which we'll talk about in a minute. In fact, now, we spend a lot of time at Docker working on making official images, and they're generally really well designed. They're updated for security issues all the time. There are often updates every few days. The team who works on them work with the people who develop the software and work out the best way of packaging that particular piece of software. They're well tested and used by lots and lots of people, so if there are any kind of problems, people have found them. They're generally pretty minimal. They only contain exactly what you need to run the code. So if you're using, the Python image or something, it's just Python. And they use recent OS versions and use the most recent base image there is. We provide older ones, but you should be using the newest one possible, either Alpine, the latest Alpine, or Debian Stretch is out this year. The newer OSs are compiled with more security hardening options in the actual binary compiles. So if you use really old base images, they actually are actually worse. There's gradual improvements. Alpine in particular has a lot of compiler hardening options, which stack protection, things like that. It's one of the things that the project's known for, and so the more recent the base image, the better. If you're trying to use something and there isn't an official image, the guidelines that we have for making official images are actually a really, really good read. I highly recommend that if you're going to build your own image, you read those first, and also try and work. If you're working with a project that doesn't have an official image, try and either work towards having one or have a suggested image for that project and ask them to put it in their GitHub repo and get everyone to work on it together, because the more people who look at these things and think about the best way of containerizing a particular piece of software, the better. And gradually over time you can get things added to the official images. We get new things added over time, and then they'll be automatically updated and so on. Work with official images when you can. Secrets. Don't commit your AWS secret keys to your Git repo because your project needs to use AWS. That sounds kind of dumb, but people do it because it's kind of convenient as well. Because it works. We need the things. Environment variables, not really very secure. You can see the environment variables on a computer from all the processors if you look in the proc file system. The Docker Secrets API and the Kubernetes Secrets API are much better systems. If you need really advanced things, Vault from HashiCorp is really good, and lots of people use that for managing all sorts of things. We're doing Docker Secrets integration with Vault at the moment, so Vault's a great product. It's complicated, but has loads and loads of features. It can issue temporary AWS keys for your services if you're using AWS, for example. But yeah, use one of those things, learn about them. They're relatively new, and so it's worth spending some time looking at tutorials and working out how to use them and how to use that workflow. But the important thing is definitely don't commit your secrets into Git. So that's 4 things you can do as a developer. I think they're all relatively straightforward things. I think you can, if you're going to do a few things, those are good ones to start with. You can, if you're a developer, those are a good place to start. Things you can do together with your ops team, with developers and ops together. It's really important to keep everything updated. There are security fixes in the in the official images and in different projects and in libraries you use and everywhere else. And if you do automated builds, you can incorporate these every time you ship a new version of your code. You can also ship all the updates for everything in the base image. But you need to be able to, you need to have tests to make sure that when you update things, nothing's broken. Library updates, often there's an API change, so you have to do a little bit of work to keep up to date. But if you do updates frequently, then the changes are small. If you do updates every 2 years because you panic because you've heard that there's a bug in the library you're using, then the updates will be much, much harder because the APIs will have changed more and there'll be more things that might go wrong. And so if you just keep doing stuff constantly, you'll find that it's just a little bit of work that you do every week or every month rather than a huge amount of work you do in a panic when there's a big security issue that has a name and a website and you read about and everyone's panicking. So the best thing to do is just make sure you have an automated build pipeline and it just works and you've got tests that you're happy with, so you're happy that things are working when you make changes. And having an automated build pipeline is just great from your general sanity and making your life as a developer better, and it's really the first thing you should do when you start building a new project is work out how you're going to build it, what CI system you're going to use, how your tests are going to run, what's the best way to test the kind of code you're writing. Image scanning is, there's quite a few image scanning services coming up now. It was a new thing a couple of years ago. The screenshot here is from one of the Docker official images, because we provide image scanning for all the official images. We also provide it for your own images. So this was I've no idea what this was. I forgot. I just picked on some random thing that had some vulnerabilities to show you what it looks like if you use an image scanning service. This is using glibc, and it's got 2 critical vulnerabilities. It links to the CVE, so you can see what they are and see if there's something that's really, really important for your code. You can use image scanning services as a kind of thing that, we mustn't ship anything that's got a vulnerability in. That's actually can be quite hard because there are lots and lots of these major vulnerabilities and things quite a lot of the time, unfortunately, and it takes a while to get them fixed. So sometimes it's worth reading the thing and saying, do I use this code? Does it matter from the point of view of what I'm doing? But ideally, you just ship stuff that has got no vulnerabilities at all. And the vulnerabilities do get fixed pretty quickly, especially in the official images. We have a whole team of people who look at the vulnerabilities in the official images, find out which bits of the software need upgrading, talk to the upstream, the Linux distros, and the people work out which things have been fixed when, and there's a load of work going on in the background using this information. Most of the time we try and have the images all clean, but there are times when there aren't, so sometimes it's worth reading the vulnerabilities and seeing if they're going to affect you, because sometimes they might be something that you're not using, but if you're not sure, just be paranoid. There are other image scanning services. I think there's some open source ones. I know that CoreOS has one. There's some that you can integrate into your testing pipelines easily. So and there's a whole bunch of work going on in standardizing the APIs and the formats of the information on scanning services, so it's easier to build them into automated tests. So you can automatically have a test suite that checks if everything's got any vulnerabilities, and fail it if it does have vulnerabilities. And as a side effect, you also get useful information like what the license is in your software that you're using. So the Docker image scanning service will look at every single component that you've used, work out which library it came from, and tell you about the vulnerabilities, which version, the licenses, and everything. It's really quite, it's pretty smart. Don't try and keep your containers running forever. I found this on Twitter. This was someone who's from their Solaris machine that had been up 6,519 days, and they had to reboot it. I remember back a long time ago when I was young, it was a sort of competition to see who could keep their servers up for the longest. That's a long time. Containers, you really shouldn't be trying to keep them up for as long as possible. You should be deploying new versions with updates. We have this kind of concept called reverse uptime, where you try and keep it as short as possible. Because the whole idea about containers and container orchestration systems is it's fine to keep taking away the components because they're load balanced and you can do upgrades all the time. And there's no reason to keep containers around. If someone, for some reason, has hacked into your container somehow because there's a security problem with your application, if you keep it up for 6,519 days, they can sit there for 6,519 days, extracting data from your system, using it to exploit other parts of your system and things like that. If it's up for 10 minutes, they have to keep attacking it every 10 minutes, and that makes his life much more difficult. So it's not a competition. Signing is part of the workflow that you can do. We have a tool called Notary, which has just been donated to this Cloud Native Computing Foundation. We've been making image signing much easier. There's a whole lot of new Docker Trust commands that we added, which those are the first 3 that are released in the current version, but there's a load more coming as well, because everyone complained that the signing was hard to understand. But Docker Trust View will tell you what signatures a container image has, which was really, you had to use the Notary tool, and it was really kind of complicated before, and you can sign and revoke signatures from the command line, and we're adding a whole load more of these commands to make things easier. The Enterprise Edition of Docker comes with whole workflows around signatures, kind of configurable, and you can also build that. We're building tooling for that for Kubernetes as well at the moment. So you can make sure that your containers come from your developers. Someone else hasn't gone and modified them on the way. Things you can do for operations. This is from the NIST Applications Container Security Guide, which is a good read. I recommend you read it. It's a very long URL, but if you search for NIST Application Container Security Guide or something, you'll find it. Small minimal OSs are better for running containers if you can. There are a few options around that. I work on Linux Kit, which, and there's CoreOS, which I mentioned before. There are other solutions as well. Failing that, at least make sure your underlying OS is updated. There are kernel issues and OS issues all the time. And again, it's like updating your containers. You need to update the base OS as well. Yeah, the NIST Application Container Security Guide is quite new. It came out a few months ago, and it's a very good read if you're interested in more detailed ideas about stuff. And then I'm going to give you a few advanced things very quickly. Salvatore yesterday said fuzz testing is powerful and recommended fuzz testing. I would also say fuzz testing is hard and not the sort of thing you can just say, oh, I want to fuzz test all my applications, but it's getting easier. Some kinds of applications it's really difficult, some it's easier. It depends kind of what things you're working on. But it's a really interesting tool, a really good tool, and for certain types of applications like Redis, it's really, really powerful and will find big bugs, both security bugs and things where your program just crashes. If you can't do the test based on your code, look, what kind of code are you writing, what kind of things can go wrong. There are lots of good places to look and learn about particular things. If you've got web-based code, cross-site scripting, just look at your code as if you're trying to hack it. Static analysis tools help. There are good linting tools. There's things like Go Meta Linter, which is a collection of tools which does loads of things. It'll give you lots of warnings. Most of them won't be about security, but a few probably will be. But most of all, work together, work as a team, help out other people, think about security, and learn. Thanks very much.